The remarkable discovery made its way through the James Webb Space Telescope when it detected a galaxy resembling our Milky Way in the early history of the universe. This finding poses a true puzzle for astronomers, as typically billions of years are required for spiral galaxies to form in their ideal shape. However, the emergence of such a harmonious structure in the early universe raises questions. Is it a miracle or a signal of unusual processes, different from previous models and theories of galactic evolution? Scientists are beginning to wonder how it's possible that the perfect spiral galaxy already existed over 11.6 billion years ago, when the universe was just beginning to take shape. Answers to these questions may shed light on how galaxies evolved in the early periods of the universe and what processes might have been at play at that time. This significant discovery became possible thanks to the James Webb Space Telescope, which detected the perfect spiral galaxy with a redshift of 3Z. This redshift indicates that the galaxy existed over 11.7 billion years ago, in the earliest stages of the universe. This discovery opens new horizons in our understanding of galactic evolution and may lead to a reassessment of existing models of the universe's development. The remarkable findings of this research effort are attributed to the work of Luca Constantine, an astrophysicist and postdoctoral researcher in the field of astrobiology. An expert in the formation and evolution of galaxies, Luca is particularly interested in the physical mechanisms underlying the structure of galaxies and the coevolution of their central black holes. Galaxies are not just random clusters of stars. They represent a complex interplay of matter and forces. Researchers envision the first galaxies as wild, unbridled collections of stars that eventually became home to population 3. It is believed that these first stars were massive and short-lived, consisting of elements different from those seen in subsequent generations of stars. Previous calculations and simulations have described the birth of the universe in the Big Bang Theory, subsequent dark epochs, and the gradual evolution of stars and galaxies. However, recent images from the James Webb Space Telescope reveal an entirely new story. A recently discovered galaxy, named SIR 2112, turns out to be a ready-made spiral galaxy when the universe was purportedly only 15% of its current age. This discovery challenges previous notions of galaxy formation and expands our understanding of cosmic evolution. Many people don't even realize that the James Webb Space Telescope can penetrate deep into time, allowing us to peer back to the Big Bang. The span of 13.5 billion years separates us from this event by only 300 million years in cosmic terms. This is just a blink of an eye. It is assumed that in the early epochs after the Big Bang, the universe was completely dark, and only after several hundred million years did the first stars appear. However, there are still no traces of these early stars. Instead, the JWST has discovered galaxies and black holes that seem to have existed for billions of years. This has led scientists to confront an exhilarating cosmological thriller. What does this mean for future research? Luca Constantine and his colleagues have contributed to this new adventure in astrophysics by dedicating their research to the galaxy named SIR 2112, which is a spiral galaxy similar to our Milky Way and has a redshift of 3. Galaxy SIR 2112 is of interest not only for its appearance, but also for its age. How can it be that in what is presumed to be a young galaxy, there already exists a structure resembling the stellar bar structure in the modern universe? Most massive disk galaxies, including our Milky Way, typically form such bars at later stages of their evolution. However, SIR 2112 exhibits an ideal bar structure, indicating that it may be considered a precursor to the Milky Way. While the structure and mass of galaxy SIR 2112 perfectly match models and assumptions, it turns out that its bar and high degree of evolution relative to the early universe raise questions. This indicates that the process of matter evolution may have occurred differently than previously thought. According to previous notions, spiral galaxies form as a result of dynamic evolution, during which a central bar of stars forms over time. This process is driven by various dynamic instabilities and interactions within galaxies. Bar formation begins when the gravitational forces inside the galaxy cause the orbits of stars in the inner part of the galaxy to bend, creating a stable bar. Subsequently, the bar acts as a catalyst for further galaxy development, directing gas and stars towards the central regions. This can contribute to the formation of active galactic nuclei or stimulate star formation in central areas. The bar also influences the chemical composition and rate of star formation in the galaxy. Years of observation and modeling have shown that bars are widespread structures in galaxies and play an important role in explaining the variety of shapes and dynamics of galaxies. Now we know that bars can form at different stages of galaxy evolution, and their presence in galaxies existing more than 9.3 billion years ago is an intriguing discovery that raises many questions about the processes of galaxy formation and evolution. Galaxy SIR 2112 is a cosmological wonder, and its discovery raises questions about what else our scientists may be missing about the processes of universe evolution. In fact, it is one of the earliest galaxies observed just 390 million years after the Big Bang. Similar to this cosmic marvel, the dream of having one's own galaxy can become a reality. For Maisie Finkelstein, this dream came true thanks to her father, an astronomer from the University of Texas at Austin. On the day of her birth, he discovered one of the most intriguing galaxies in the universe, and since then, it has been named Maisie's Galaxy. It is one of the earliest and most distant galaxies ever observed. Finkelstein and his team are studying light signals from very old galaxies using JWST, allowing us to see them with incredible clarity. This marvel of technology enables the study of objects more than 13 billion light-years away. Maisie's Galaxy, with its redshift Z equal to 11.4, is one of the earliest and most distant objects ever observed. Finkelstein's observations have also confirmed the existence of many other very old galaxies, prompting us to consider how modern galaxies, including our Milky Way, formed. Studying the process of forming our galaxy can help us better understand the evolution of the universe and the mystery of its oldest objects. Just a few hundred million years after the Big Bang, an amazing process of universe formation began, passing through several complex phases. In the very first stage after the Bang, when the universe was an extremely hot and dense soup of subatomic particles and radiation, cooling began, leading to the formation of the first atoms. This time, known as the Dark Ages, preceded the formation of the first structures in the young universe. Experts call them halos of dark matter, which formed from areas of increased matter density, attracting more substance and creating the first stars and star clusters. It is believed that a galaxy the size of our Milky Way formed by merging several smaller galaxies and gas clouds. In the early stages of its development, the Milky Way was likely irregular in shape, acquiring its spiral structure only after further mergers and matter accretion. Interestingly, the process of galaxy formation is closely linked to the development of chemical elements. The first stars consisted mainly of hydrogen and helium, but as they completed their life cycle, the elements they produced spread throughout the universe, enriching it and becoming the building blocks for new stars and planets. However, discoveries by JWST show that our assumptions may be flawed. So far, we have not detected any of the early stellar giants or irregular galaxies in the young universe when, according to previous assumptions, it should have been dark and chaotic. Instead, even in its early stages, the universe exhibited remarkable harmony and order. These discoveries raise new questions and compel us to rethink our understanding of the origin and evolution of the universe. Perhaps it is much older than we thought, or maybe it had no beginning at all and has always existed in its perfect form. It's amazing how our understanding of the universe is constantly changing thanks to new discoveries and research. Sometimes we encounter facts that don't align with our expectations and familiar theories, prompting us to rethink our views of the world as a whole. Discoveries made with the help of JWST turn out to be both exciting and thought-provoking. How could the universe be so organized and harmonious at the very beginning of its existence? This reminds us that our understanding of the universe is still very incomplete, while also showing how much more we can learn. It seems to me that these discoveries also underscore the importance of scientific exploration and being open to new ideas and data. Each new discovery opens up new horizons of understanding for us, and it's an exhilarating journey of exploration that never ends. And ultimately, these discoveries remind us of how mysterious and wondrous the universe is, and of our humble role in this endless quest for knowledge. Have you ever thought that the universe will never cease to amaze you? Share your thoughts on the latest discoveries that contradict traditional views of the universe's beginning. How do you perceive this new information? Don't forget to leave a like if these discoveries make you ponder the mysteries of space.